Okay, now we're going to solve the game Sortum. So 4 balls, red, yellow, orange, and green, are placed in baskets 1, 2, or 3 with at least 1 ball in each basket. Our rules tell us that the red and orange ball are in the same basket and the green ball is not in basket 3. And if we check for R and O, the red and orange ball being in the same group, then we can quickly eliminate one of our game boards. When we realize that we need at least one game piece in each group, we can eliminate a second game board. And the green cannot go in 3 eliminates 2 more possible answer choices, leaving us with only 1 possible game board. Our second question asks, if R is in basket 1, which of the following could be in the third basket? So we're asked to do an action here, that is put R in basket 1. So we're going to start with completing that action, looking at our rule list and seeing what it calls in, and we see that R in 1 brings in the O with it. The next thing we want to do is count up what is left. Well, we know we have Y and G left to place. Finally, our rule 2 says that G can't be in group 3. But between spots 2 and 3, we know that they each need to have at least 1 game piece, and we only have 2 game pieces left. So we know that G isn't going in 3, but let's think about what would happen if we tried to put G in 1. Well, the Y would then only have 2 and 3, and it would somehow need to fill both spaces. The Y needs to only go in one of those spaces, and the other one needs a piece. So we're definitely not putting G in 1, and we're not putting it in 3, which means we have to put it in 2. And if that's the case, the Y needs to fill up that third space. So the only possible game piece to go in the third basket is actually Y. Now this next question asks us to completely determine our game board, and we see our first option, Y in 3. Well, we already have a game board with Y in 3, and does it completely determine? Well, no, because the RO brick and G in 2 can freely trade off. The only rules we have are that G can't go in 3, but because G is not trying to go in 3, it can definitely Next, we can test the same thing with G in basket 2 and see that RO and Y can switch off in those 1 and 3 spaces. The RO block can go in 1 and the Y can go in 3. Because there's options like that, this is not a completely determined game board once we put G in 2. And if we try locking in R and O in 3 and ask ourselves if this completely determines our game boards, we see that Y and G can freely trade between the first and second basket. They are not limited to being in one of those places, and so we don't know who's going where, so they are not limited and it is not completely determined. We can try that again with G in the third basket and see that the RO block and Y can trade off. We don't see any constraints there, so they can trade and this is not completely determined. Now lastly, we put Y into 1, and then we should be looking at this RO brick and the G piece. Now we know that the G can't go with the Y in 1 because R and O must stick together and they're not going to satisfy the least 1 brick in 2 and 3 rule. And then we realize that G is also locked out from 3, so if G's not going in 1 or 3, G has to go in 2. And this starts to feel like the right answer to a completely determined question. Things are going to start falling into place. Now lastly, with the RO brick, we see that spot 3 is empty and that basket needs to have at least 1 piece. So R and O are forced into basket 3, all of our game pieces find a home, and none of them can move around. For question 4, we're asked, what is a complete and accurate list of all of the balls that could be in the third basket, but not at the same time necessarily? And we've seen R and O in the third basket, and we've seen Y, and that just leaves G to test. And rule 2 says G can't go in 3, which means that the complete list of who could go in 3 is going to be Y, O, and R. And finally, our last question removes the restriction of G in 3 and asks us to put R and O into the second spot. So now we have G and Y, the green and yellow balls, to trade off between the first and the third basket because the green ball is now allowed into basket 3, and we're asked a complete and accurate list of all the balls allowed in the third basket. It doesn't tell us that they have to be at the same time. We're just listing what are all the possibilities of who could go in basket 3 once we lock R and O into 2. And we see that once we do this, Y and G can freely trade between the first and third baskets. So our complete list of who could go in basket 3, well, it could be green or it could be yellow, so both of those make up the list of who could go in 3, but we know it's not going to be red or orange.